with this.
Because this boy Caleb Wang the coronavirus, I think, because
We're
if
gonna get
all the
started.
days he's asking.
We are in 6.6.
6.6.
Talking about
Unusual mammal.
unusual animals. So let's get started. Growing in a pouch, marsupials from the order Marsupialia are mammals that have a pouch. The pouch or marsupium is where the young develop. A few marsupials do not have pouches but still use marsupial reproduction. Marsupials include kangaroos, opossums, wombats, koalas, numbats, Tasmanian devils. Unlike placental mammals, the length of time for development inside the mother is very short, and mothers give birth to very tiny, underdeveloped young. Once born, the newborns will crawl up through the mother's fur and into the marsupium, and there they feed on milk and continue to develop. This is what a 1-week-old Joey looks like in the mother's pouch. So they're hanging out in the pouch. Keep reading.
Joey.
Kangaroo.
Baby dogs, puppies, they're called Joeys. Okay, king of jumpers. The most famous of all the marsupials is probably the kangaroo. Kangaroos, found in many parts of Australia and New Guinea, are the largest marsupial and the largest hopping animals. The largest kangaroo is the red kangaroo, which can grow than more than 150 centimeters, which is about 6 feet tall, and has a 3-foot tail and weighs up to about 200 pounds. The rat kangaroo is only 12 inches tall and weighs about 500 grams, 17 ounces. Although bouncing around may seem awkward, scientists have determined that a kangaroo's hop is more energy efficient than moving by running on all 4 legs. This efficiency enables kangaroos to travel at speeds of about 25 to 30 miles per hour, 40 to 48 kilometers an hour, over long distances. The kangaroo uses its muscular tail as a prop and to balance when leaping. Even though their forelimbs are much smaller than their hind limbs, male kangaroos will sometimes use them for fighting. Kangaroos are active in intervals during the day, taking time to sunbathe in the warm afternoons. When traveling together in groups called mobs, kangaroos eat mostly grass and can live without drinking water. During extremely dry spells, they will dig for water or eat roots that store water. This is a red kangaroo right here. Probably the most famous one, which you guys will normally see. All right, let's go. Banded eater. The numbat, a pouchless marsupial, is found only in a small area of southwest Australia. These animals do not usually weigh much more than about 1.5 and have 5 or 6 distinctive white stripes across the rear portion of their back. A numbat's long, slender tongue, which can extend out several inches, fits into termite tunnels and extracts the numbat's favorite food. Because of their distinctive markings in their diet, numbats are sometimes called banded eaters, anteaters. I think this is it right here. This is a numbat, or a banded anteater. And then we're going to talk about the koala, the Australian teddy bear. The koala wins the prize for the pickiest eater. Koalas feed almost exclusively on eucalyptus leaves. That's the only thing. During certain times of the year, they will not eat the leaves from some trees because the trees produce. What happened, Anderson? There we go. Because the leaves produce a distasteful acid. Koala means one who never drinks. Although koalas will drink water in hot and dry weather, they get most of the water they need from the leaves they eat. Koalas are gray with tufted ears and a beak-like snout. These arboreal creatures tend to live by themselves, except during mating season. Koalas often pick out about a dozen trees and spend most of their life. If one koala climbs onto a tree owned by another koala, it may be attacked. Occasionally, a koala will go down to the ground to lick up soil or gravel that aids in digestion. A baby koala develops for about 6 months in its mother pouch and then clings to its mother's back for protection and transportation. All right, then we have the wombat, which is the living bulldozer. The wombat, found throughout Australia, is a shy animal that digs a maze of burrows. The wombat is chunky and has short legs and the tail hidden by coarse brown fur. It's been its feet have scoop-like claws for digging because of their appearance and burrowing habits. Australians sometimes call them badgers. A wombat has a rear-facing pouch to prevent dirt from entering as it digs. If you stare at another wombat, you may see her joey looking at you as the mother runs away. Wombats eat grass, dark roots, and fungi. Their incisors grow continuously and must be worn down by chewing. All right, now we have the headstrong gluttons. The Tasmanian devil has a fierce expression on a bear-like head with a pointed snout. It is the size of a very large house cat and has a bushy tail that is about half the length of its body. It is covered in dark fur with white chest markings. The Tasmanian devil can consume 40% of its body weight in food in 30 minutes and never seems to be satisfied. These animals are primarily scavengers, eating whatever they find, including meat, bones, and fur. The Tasmanian devil is easily recognized by its dreadful snarls. Its snarling and unending appetite earned it the name devil. So it eats a lot. Then we have the dramatic performer. Opossums are the only marsupials found outside Australia and its surrounding islands. The over 60 species of these nocturnal omnivores can be found from the southern tip of South America all the way to southern Canada. The North American opossum is a cat-sized animal with the appearance of a rat. A coat of coarse gray fur and a white face. Opossum is an Algonquian Native American word that means white-faced, referring to the Virginia opossum's appearance. Opossums are known for their ability to play dead. When an opossum feels threatened, it will go limp, close its eyes, and its tongue hang out of its mouth. The attacking animal will lose interest and leave. An opossum can play dead for 1 minute to 6 hours. Its act is so good that it can be handled and will not move. With a prehensile tail, the opossum is an expert climber. Once its young are weaned, they will ride on their mother's back. Okay. All right, so we have the wombat right here.
What you are laughing, mister?
Because it makes me, I don't know, that just makes me laugh. The opossums. We'll talk about it. So right here we have the wombat, okay? And the wombat is kind of like a little bulldozer. It digs and digs, and so it lives kind of in tunnels and stuff like that. But it kind of looks like a mini bear. And from what I heard, it bites and chews and stuff like that. And so it can be nice, but also can be kind of mean. And then we have the Tasmanian devil. These guys are crazy, all right? I've seen, there's videos of them like tearing up meat and stuff like that. When they fight, they just kind of mix together, and it's, I don't know. I wouldn't want to come in contact with them. Even though it's like the size of a small, like a cat or a small dog, I'd be more afraid of that than anything else, because that to me would be much scarier. I'm sorry, let me do this again, so see if Samuel can see the screen. All right, there you go, Samuel. All right, then we have the possum. The possum is, I think there are some here in Honduras, I'm not sure. But there's definitely some in the United States. And so it covers a lot of North and South America. So these guys, the way of protecting themselves is they play dead. When they're scared, they just fall over and play dead. And you can grab them and you can move them. And like, I've seen videos of people who've moved them around and they stay dead. And so they're good at it. And then once they feel like they're safe, they'll wake back up and then they'll go. Because to me, that I find that funny. Can you imagine a human doing that? Like, say we're in class and I scare you, all of a sudden you go. How would you feel? I would find that hilarious. Personally, I would find that hilarious. Okay. Okay, oviparous oddities. All right, let me see how much more we have of this chapter, and then, okay.
Mister, one question.
Yeah.
How we say ornitorrinco in English?
I have no idea.
Platypus.
Mister, you are an American. You need to know.
And? I don't know it's in Spanish. Okay.
You don't look
Animal that you put on last page. Mr. Naranjo.
The platypus.
Platypus.
I don't know. Let's keep reading, okay?
Ornitorrinco.
5 different species are in the mammalian order Monotremata. Okay? Zoologists were discovered that these animals are oviparous or reproduce by laying eggs. Yet they have unique mammalian characteristics of hair and milk. So they're mammals, but they produce eggs and milk. So there's echidnas and platypuses. So we have an echidna right here and a platypus down here. Is this what you're talking about, Caleb? No?
This one right here of the right side.
This one right here? Yeah, that's a platypus. All right, let's read about these guys. Spiny anteater. Echidnas, found in Australia, New Guinea, and Tasmania, have long snouts. There's no teeth and long, sticky tongues for lapping up insects. There are 4 species of echidnas: the short-beaked echidna, and the 3 species of long-beaked echidnas. Because their bodies are covered in fur with specialized spines for protection, echidnas are also called spiny anteaters. An echidna has strong forefeet with flattened claws for digging when disturbed or attacked. He will either quickly burrow into the dirt, leaving its spiny back exposed, or roll into a tight ball. So it has its spines on the back that shoot out, and that's what protects them, because if you try to eat it, it'll put them in the mouth. A mother echidna usually lays 1 rubbery egg that she carries around in a fold in her skin. The young hatches after about 10 days in the mother's milk. It's kind of like it gives birth like a bird, but it grows like a mammal. So it has an egg, and then it grows like a mammal with milk, and it has hair and stuff like that. Fur. The young hatches after about 10 days and is nourished by its mother's milk. The baby echidna stays in the pouch for 6 to 8 weeks, so about 2 months, until the spines grow. The spines develop, and the mother then leaves the baby in the burrow or nest and returns periodically to feed it. All right, now we're going to talk about a platypus. Found in Australia's freshwater lakes, lagoons, and streams, the platypus is one of the most distinctive-looking creatures in the animal kingdom. Its thick, waterproof hair is similar to an otter's, and its brown-black color provides camouflage. Although its bill resembles a duck's bill, it's actually fleshy and covered with skin sensitive to touch and vibration. So it's not hard. It might be a little hard, but it's a little soft as well. The platypus hunts for food while swimming. The webbing on its feet makes it an excellent swimmer. Because the platypus's keen eyes and ears are covered with skin folds while underwater, the platypus uses its bill to detect electric current produced by the muscle movements of its prey. It can stay underwater for 5 minutes looking for crayfish, shrimp, and insects. So it's not a fish, so it can't breathe underwater, but it can hold its breath for about 5 minutes. The platypus has claws on its feet to give traction on land. In males, you can't see. We'll do it one more time. All right, this is for Samuel so he can see. The platypus has claws on its feet to give it traction on land. In males, the hind feet have a sharp spur connected to a venom gland. When a baby platypus hatches from the leathery egg, it will lap milk secreted from its mother's milk glands. Okay, let's talk about that. The back part of its legs, it's webbed feet, so it's connected right here. So imagine like a piece of flesh there. But its back part, it has like a hook, and there's a venom. So that's poisonous. So if it gets you with that, you can be poisoned with it. It's venomous. And then when it hatches, the same thing with an echidna, it drinks milk. Because of the platypus's unique features, many scientists
Mister,
see the proof of evolution.
like a cat
Yeah, kind of.
that they may get out the nails.
Yeah, kind of like that. However, we see instead an animal that has been specially designed by God to survive the environment in which it's been placed. So it doesn't come from evolution. It's just a special creature. Okay, so I want you guys to read this on your own because we're going to move forward. And I want you guys to look at that and this as well. I want you guys to look on those on your own. So it talks more about the platypus, and then endangered animals, okay? Which I don't know if we talked, I don't think it was with this, it was in 5th grade we talked about it. But you guys learned in 5th grade, we talked about animals going extinct, okay? So this talks more about endangered and extinct animals. You guys already know about this. Extinct means no longer exists, or it's no longer seen. Endangered means it could no longer exist. And so you want to be able to protect it. So there's certain, like the gray wolf and the bald eagle are endangered. And there's many other animals that have died because they hunted and stuff like that. So they no longer exist. So I want you guys to read that on your own and discover that. Okay. This is the section review right here. We'll read it real fast. So it says, what is the pouch in which marsupials carry their young? So the name of the pouch that they carry. And what does a kangaroo use its tail for? Remember, for 2 things, when it's standing and then when it's hopping. And then what is the one thing that koalas eat the most? What food forms most of a koala's diet? After that, we have what marsupials are found outside Australia and its islands. I think there's only one. And then what characteristics make monotremes different from other animals, okay? And I think that's talking about the echidna and the platypus. Now we're gonna move on to chapter 7. And we're gonna start learning about birds. Okay, so you have to do that section review, and then we'll get started with this one on chapter 7, okay? All right, so in this chapter, what we're gonna do, we're gonna be learning about internal anatomy, which is its body structure and what it looks like, its senses, what bird senses and stuff like that, learn more about its feathers and what's their purpose, how they fly, the bird's behavior, knowing the different features of birds, and so like there are different types of feathers, their feet, and their beaks, and the different groups of birds, okay?
Okay.
Let's get started. Let me have Anderson. I want you to read this section over here.
In chapter 7.
In chapter 7.1. It says design for flight.
Design for flight. Birds in class 8 are some of God's most fascinating creatures. Their magnificent plumage, feathers, their mellow songs, and their ability to fly reveal God's endless creativity and marvelous provision. God cares greatly for the birds, but he holds an even greater love for you. Behold the fowls of the air, for the sow not, neither do they reap, nor gather into barns, yet your heavenly Father feeds them. Are you not much better than they? Matthew 6:26.
Very good. And that it's saying that birds don't have to work for their food. They don't have to, God provides everything. And so even though they have other stuff and they're very beautiful, God loves us even more because he takes care of us, okay? Now, Anderson, continue. It says ornithologists.
Ornithologists, scientists who study birds, classify about 10,000 living species of birds. All members of Class A are bipedal, two-legged, warm-blooded vertebrates with feathers, scaly legs, and wings. Although some extinct birds have teeth, no living birds have teeth, but the internal and external body, the structure of most birds, is designed especially for flying, whether for short or long distance. Flightless birds that have an anatomy designed for life on the ground or in the water still fit every characteristic of Class A.
Very good. So birds are meant for both water and land. And so we see right here that that some have different characteristics, but they're all part of the class Aves. We can see right here that it says it's warm-blooded vertebrate with feathers. So it has a backbone. It's warm-blooded, so it doesn't have to, it's not like a reptile where it needs the sun to keep warm. It produces its own warmth. It has feathers, scaly legs, and wings. And that all meets the class of avids. All right, so let me have Caleb, will you read this section right here, a lightweight structure?
A light wheel structure. Avian pertaining to birds. Bones were created to be very strong, yet much lighter than the bones of other animals or of people, unlike the solid bones of most other any other animals. Bird bones are usually whole and strengthened by strong internal cross bracing like those of a seal bladder. The light white skeleton of a bird is about 5% of its body weight. A human skeleton is about a 14% of its entire body weight. For example, the Andean condor, the largest flying bird, was a wingspan of up to 3.2 meters.
Very good.
Yet it weighs only about 15 kilograms, 30 libras, about as much as a medium-sized dog. Some flighter birds have solid rubber bones that give them strength and support. They stand and run.
All right, let's look at this picture of the avian bone. It's not that big, all right? There's a lot of air inside of it, but it has these cross sections right here, like they do on bicycles, on the wheels of bicycles. What keeps them strong. The same thing inside of their bones. So they have these cross reinforcement struts, that's what they're called, but cross sections keeps them strong so they don't break so easy. It's kind of like a straw. If it didn't have anything on the inside to keep it strong, I mean, it's lightweight, but
Something extra.
yeah, it would bend and stuff like that. Okay. Let's move on. We have the bird skeleton right here. I mean, they all have a skeleton. So you see the ribs and the sternum right here. There's the ribs, the coracoid, which is what connects the two, the furcula, which is in the front. Vertebrae are what everyone, all mammals have vertebrae. The skull, backbone, scapula, pelvis, femur. You can see a up close view. So this is what its wings look like and something like that. Yes, Caleb.
Did an animal already extinct?
What? Is there a bird that's already extinct?
Mm-hmm.
Yeah, there's one called the dodo bird. It's probably one of the most famous ones. That one is extinct. Okay, Diosa, will you read for me?
The skull of a bird is also made for lightness and strength. The flat bones of the skull are very thin in many places. Thin, bony supports take the place of the heavier facial bones of other animals. To further reduce weight, instead of teeth and jaw bones, birds have toothless bills made of keratin reinforced by lightweight bony struts. Birds' skeletons have several other characteristics that aid in flight. Flying birds have a very strong sternum with a large ridge called a keel. The keel provides the necessary attachment point for the powerful flight muscles. The clavicles, collarbones of a bird are fused together, forming the furcula or wishbone. The furcula strengthens the skeleton during flight. Birds are the only vertebrates with a furcula. The wing bones of most birds are also designed for flight. The humerus upper arm bone is short, which makes it strong. This is necessary because the major flight muscle attached to this bone to flap the wings. In comparison, the ulna and radius lower arm bones are long, giving the bird a long forearm.
Very good.
I need to keep reading?
Yeah, finish until here.
Okay. The avian palm is a rectangular bone with a hollow center. Human palms have several bones, but God designed birds to have only one bone, reducing weight while increasing strength and rigidity through fewer joints. The bird's thumb bone supports the alula, a retractable group of feathers on the front of the wing, while the finger bones support the feathers on the wing tips. The strength to fly.
Very good.
Countless.
So the alula, a retractable group of feathers on the front of the wing, while the finger bones support the feathers on the wing. So this is what it's just describing right here in that last section, okay? It talked about the furcula, which is what protects. It helps give a lot of strength to it. You see the furcula right here? So it just adds extra strength to, I think we call it the wishbone. Have you ever ate a chicken or a turkey and it has that one little piece like that? And whoever pulls the side, you give it to somebody else and you pull it, and whoever gets the bigger side wins. That's what they're breaking right there. So yeah, that's it. Let's keep reading. The strength to fly. Luis Mario, will you read this?
Yes, the strength to fly. Countless inventors have tried to fly by fastening wings to their arms and flapping like birds, but all have failed for one simple reason. No matter how efficient the winged man lacks the arm length to
Strength.
flap himself off the ground. The muscles of flying birds are engineered to meet the power demand of flight. The most important flight muscles of pectorals, which respond to muscles of your chest. The pectoral flap the wings of the bird to flip the bird off the ground and produce the speed needed for flying. The pectoral alone can comprise 33% of the body weight, some birds giving them plenty of strength to fly. Your pectoral muscle pull your arms and forwards, while your back muscles pull your arms towards your back. God engineers designed birds so that the pectoral raise the wings as well as longer them. Each pectoral is major. The larger 2 of 4 pectoral muscles pull the wings down to produce
Next page.
the power stroke. A strong pendant from each pectoralis monitor passes through the bird's shoulders and attaches to the top of each humerus, pulling the wing up the rope and pulled by these muscles to raise the wing. God eliminated the large strong back muscle in birds, keeping the weight concentrate low in their chest for stability in flying.
Very good. So this right here, these are our pectorals, okay? These muscles here in our chest, these are our pectorals. Some people may have big pectorals, but for the most of them, it's not big enough to fly. You can't flap hard enough to fly. Whereas in the bird's hat, it covers about a third of their body weight. So of course they have the strength to flap, but also we are too heavy. Our bones are too thick and too condensed. They have vents, air in their bones, and so they're lighter. They don't weigh as much. So that's why they're able to fly. Okay, we're going to talk about air supply. Samuel, can you see?
No, mister, I cannot see any.
Okay, well, we'll give you copies of the book. I'm going to read from here. Constant air supply. During flight, a bird's muscles require large amounts of oxygen, and the respiratory system has to be able to supply this need to prevent exhaustion. So when they're flapping, they're going to be breathing a lot. Not only must the bird's respiratory systems meet the unusually high oxygen needs, but also must do the same at high altitudes where the air is thin. Some birds may fly over 30,000 feet in the air, an altitude that would cause many other animals to suffocate from lack of oxygen. To supply a sufficient oxygen to the bird's muscles, God provided birds with a unique respiratory system. The respiratory system of birds is not as simple as that of mammals. A bird does not have a diaphragm. Instead, air is pumped through the lungs as chest muscles expand and contract the thoracic cavity. Do you guys remember the project you did with the balloon that represented the lung? That bottom part that you pulled, that's the diaphragm. They don't have that. They have muscles, chest muscles, which help expand and contract. So they need to be able to breathe, and that's what helps them. When a bird flaps its wings during flight, it moves its chest muscles faster, allowing the bird to breathe more vigorously when it needs oxygen the most. Avian lungs lack alveoli. Instead, they have tiny tubes called air capillaries, which allow air to flow through the lungs instead of just in and out. This unique respiratory system delivers a much steadier oxygen supply during the breathing cycle than other designs do, and allows high oxygen transfer rates even at great altitudes. So they have a different lung system which helps them breathe. When a bird inhales, fresh air enters through its trachea and passes through the lungs into the large air sacs behind the lungs. As the bird then exhales, the fresh air from the air sacs flows forward into the lungs. Oxygen and carbon dioxide are exchanged before the bird inhales again. This inhalation forces the now stale air out of the lungs and into more air sacs in front of the lungs. Finally, the air leaves the bird during the next exhalation. Thus, the bird inhales and exhales twice to move each breath of air through its respiratory system. In effect, the bird has 2 breaths of air moving through its system at once. This design allows birds to extract the maximum amount of oxygen from every breath they take. So they basically are breathing twice. Every time they go, that's like 2 breaths for them. We have 1, but they have 2. Because birds produce large amounts of heat during flight but cannot sweat, the respiratory system also helps cool the body. Air tubes connect the air sacs to the hollow cavities of the major bones, allowing air to flow in and out of the bird's skeleton. With each breath, cool, fresh air moves into the air sacs and hollow bones, absorbing excess heat from the organs. Evaporation of moisture within the air sacs also aids in cooling. Without this special cooling system, birds would overheat. So they're flying all the time. And so if they didn't have a way to breathe and have an ability to cool down, they'd be too hot and they'd die. For example, I don't know if it's ever happened to you, but have you ever been playing outside, playing soccer when it's really hot and you feel like you're gonna pass out?
Yes.
It's getting too hot. And so the birds have special ways they can relax, calm down, and not die. All right. Let me keep reading. All right. So we have full circulation. A bird's massive flight muscles must contract with tremendous force, sometimes several times per second per hour at a time. To function, these muscles require large amounts of food and oxygen, which must be delivered by a strong blood supply. The high blood volume requirements of the flight muscles are met by the strong avian heart. So they have a strong heart, which is considerably larger in relation to a bird's body size than are the hearts of other animals. So our heart's about the size of a fist. Their hearts would be bigger in comparison to their body. And a bird's 4-chambered heart circulates blood in a pattern similar to that of humans and mammals. Now we're going to talk about digestion, rapid digestion. Because flying requires great amounts of energy, birds must eat often. Some very young or very small birds, which have high metabolisms due to their size or growing rate, may eat their body weight in food each day. Birds must also digest their food rapidly. The faster they digest it, the sooner they can use the energy and the less digesting food they have to carry. Unlike other animals, birds do not store much solid or liquid waste within their bodies, as the extra weight would hamper flight. So they don't have like layers of fat like some animals do, like mammals have the blubber or something like that. They don't have that because they need to be able to be lightweight to fly. Many birds have a crop or storage sac in the esophagus to moisten food and release it in the steady stream to the rest of the digestive system. Since a bird has no teeth to chew its food, its stomach has a special section called a gizzard, which grinds food to make it more easily absorbed in the intestine. So in the gizzard, it's like a little sac. There's a bunch of like pebbles, rocks, and stuff like that. So when it brushes up against it, it kind of pulverizes and destroys it. Sometimes birds swallow gritty material like gravel or sand to help grind the food. Ostriches have been known to have over 5.5 pounds of a grinding material in their gizzards. Unlike a mammal, which has both a large and a small intestine, a bird has only one intestine. So they only have one intestine. Now let's talk about sight. Of all God's creation, birds have the best eyesight. Good eyes are especially necessary for predatory birds to spot their prey from high altitudes. The keen eyes of the eagle, for example, can discern a crouching hare over 1.5 kilometers away. Other birds use their excellent eyesight for spotting insects in flight or keeping track of distant predators. The eyes of some owls are so sensitive that they can see as well in shaded moonlight as the average person can see in the daytime. Birds' eyes are huge compared to their heads. In most birds, the brain is positioned far back in their skull and tilted to make room for their eyes. Because birds cannot move their eyes much, they must turn their heads instead. But this is not a problem for birds because they have very flexible necks. The owl cannot move its eyes at all, but it can turn its head 180 to either side without moving its body. So it can, facing straight, it can turn all the way to be 180, the same thing. So it looks like they can turn their head 100 all the way around, 100%, but they can't. That's like being able to look exactly, like if your head was facing this way, but on your back. Okay, that's how good their eyesight is. They can see everything. They can't move their eyes, but they can move their heads. Let me see where we're at. Should be about done with this. Okay. Yeah. Okay, let's keep reading. Come on, there we go. The eyes of most birds are on the sides of the head, providing a wide field of vision for detecting danger. These birds have primary monocular vision, in which each eye sees a very different portion of the world around them. Birds with predominantly monocular vision can see most of their surroundings at once, making such birds very hard to sneak up on. Some birds, such as the woodcock, can see in all directions at once. The eyes of many hunting birds, such as owls, hawks, falcons, and eagles, are positioned farther forward to give binocular vision, in which both eyes can focus on the same object. Although binocular vision provides a narrower field of view than monocular vision, it gives keener vision at long range and such improved depth perception at shorter ranges. So let's look at these field of visions. So we have this right here is the woodcock. It can see from here to here and then here to here. So both eyes see right here and both eyes can see right here when turned around. So basically it can see 360 degrees, everything. Whereas the owl, left eye here, right eye here, both eyes, but it can turn its head to look the same thing, almost 108 degrees each way. These attributes are important to predatory birds that must spot their prey from long range but kill at close range. Hearing. Most birds have very sharp hearing. Owls, for example, hear well enough to hunt small rodents by sound alone. Some other birds, like the cave swiftlet, use their sensitive ears to see in the caves. These birds produce clicking sounds as they fly. Then they listen for and navigate by the echoes. So they're trying to see where the sound clicks off the wall so they don't run into the wall. Smell. Although many birds apparently lack a good sense of smell, some have excellent noses for scent. For example, the king vulture, which feeds on dead animals, uses its keen sense of smell to locate carcasses beneath the dense leaf canopies of Central and South American tropical rainforests. So they have good vision, good hearing, good smell. Kind of hard to trick them. Feathers for flight. Now we're going to talk about the feathers. There's a mosquito here and I want to kill it because it already bit me 3 times. Birds are unique because they have feathers that insulate their bodies against extreme temperatures and protect them from climate conditions. The feathers also form the bird's smoothly tapered, streamlined shape, allowing it to move easily through the air and from the broad area of its wings, allowing it to fly. A bird, even a small one like a sparrow, will have up to 3,000 feathers, so they have a lot of feathers. Contour feathers. There are several different types of feathers on a bird, each with a different purpose. The contour feathers are strong feathers found on the bird's body, wings, and tail. So those are probably the big ones you'll see. If you pull a feather, that's probably the ones you'll see. All the contour feathers of a bird point toward the tail of the bird to aid in streamlining. The flight feathers, which provide the necessary wing shape for flight, are special contour feathers. The bird's wings are only narrow supports for the flight feathers. Stripped of its feathers, no bird could get off the ground. Have you ever heard of clipping a bird? No? Anderson, have you heard of clipping a bird?
No.
Okay, so when you clip a bird, you clip its flight feathers. And they do that with a lot of macaws. If they have them as a pet, they'll clip their flight feathers so they can't fly away. They can fly a little, but they'll just always go down. They won't get up and go away.
Mister, one
Yeah, Luis.
cousin was having one, I don't know, he was having a bird, and they do that for he don't escape.
So they don't escape. That's what they do. Primary flight feathers extend from the bird's hand to the tips of its wings. The secondary flight feathers extend from the back of the ulna and provide the central section of the wing with the shape necessary for lift. So the flight feathers help with the shape. So it has a smooth body, but its wings also kind of extend out so it can able to flap and lift up. The tertiary flight feathers overlap the secondary flight feathers against the bird's body. Most birds have only 3 or 4 tertiary flight feathers per wing. So there's different types of feathers. It's not just one feather, there's different types. As you can see right here, this is the primary flight, secondary, and the tertiary flight feathers, contour feathers, and the alula right here. So these are all the feathers that they need on the wing to be able to fly. Talk about insulation feathers. Beneath the contour feathers lie the down feathers, soft, fluffy feathers close to the bird's body that provide excellent insulation without adding much weight. These feathers insulate by trapping air to form a layer of protection against heat loss. Birds often maintain a body temperature of 43 degrees Celsius without the insulating effect of their down feathers that could survive only in the warmest climates. Because of their thermal efficiency of feathers, some birds are able to live actively in frigid climates or fly at altitudes where the air is bitterly cold. Migrating swans and geese sometimes fly at very high altitudes, where temperatures can drop to 48 degrees Celsius. Negative 48 degrees Celsius, sorry. Because geese are especially well insulated, many warm quilts, jackets, pillows, and sleeping bags are filled with their small feathers and fluffy down. Feather structure. Each feather has a shaft, the hard, hollow backbone of the feather. Attached to the shaft are thousands of individual projections called barbs. We're going to look at it right here. See these barbs right here? The barbs of contour feathers are zipped together by tiny hooks called barbels that run along their edges. The connected barbels form the large flat vein of a contour feather. Down feathers do not contain barbels, giving these feathers their softer look. Feathers grow from follicles in the bird's skin. Feathers are made of keratin, the same protein that forms hair and nails. Also, like hair, a feather grows from its base, which has a blood supply to provide nutrition needed for growth. A network of capillaries grows up into the base of the shaft during growth. But at maturity, the blood source disappears, leaving the shaft hollow and light, manicured for flight. If a bird's feather become too dry, their barbs may become brittle and break. This would hinder the bird's ability to fly. Aquatic birds also need well-kept feathers to prevent their plumage from becoming waterlogged. To help keep their feathers in good condition for flying, birds frequently preen or groom themselves. So they'll take out some of the feathers they don't need. So let's look right here at the structure of a flight feather, okay? This is the inside. Each is connected by each barbs, and some barbs have hooks and phalanges. So these ones will connect to these ones right here. So they stay on their body. All right, we're almost done, guys. When preening, the bird pulls the contour feathers through its back to zip the feathers. It's like connecting like this, kind of like hooks, like that. Barbels in place, preparing the feathers for flight. Almost all birds have a special preen gland near the base of the tail. This gland produces oil that the bird spreads over its feathers with its bill. The preen gland's oil helps condition and waterproof the feathers. To help them preen each feather from their body, God gave most birds 13 to 25 neck vertebrae, more than any other animal, so they can move their neck better than any other animal. Molting. At least once a year, a bird completely molts to replace its old, broken, or missing feathers as new ones are grown. Although molting takes place at a certain time of the year, most birds do not lose all their feathers at once. They will notice many molted feathers in the spring and fall. In the spring, some kinds of birds undergo a partial molt, developing colorful plumage for courtship. Changing feathers can also provide protection through camouflage. The ptarmigan grows either white feathers for the winter snow or brown summer feathers to blend in with its rocky surroundings. Do not collect feathers. In the United States, it is a violation of federal law to possess feathers or any other part of most bird species. Several other countries have similar laws. They say don't collect feathers, but that's a lie. I used to collect feathers when I was a kid. I'm sure other people have collected feathers. I don't understand how it's against the law, but oh well. So this is what winter plumage looks like. This is what the feathers look like in the winter. They'll molt them or get rid of them and then have the summer one. All right, so you had this experiment you're supposed to do down here, but you can't do it because it needs a certain thing. So guess what? You don't have that one to do. Everything continues. Let's see. Yep, that is the end of the chapter, I believe. Let's get to the end. All right, this is your section review, 7.1. Read the questions real fast. What makes bird bones lighter than those of most other animals? What bone provides a mounting point for the bird's powerful flight muscles? What are the most important flight muscles in a bird? Define crop. What organ makes up the bird's lack of teeth? Which type of feather provides a bird's streamlined shape? List the 3 parts of a feather. What do birds do to keep their feathers in good condition for flying? Remember, it's preen. And define molting. What is molting? All right, so you have to do this. I also want you guys to read section 7.2. This should be only 4 pages long. And then you'll
Mr.
Yes.
Mr. Naranjo, and we need to do section review 6.6.
Yeah, do that last one in mammals and then do the first 2 for birds, okay?
Okay.